Okay, in this section, again, we're looking to identify that a figure is actually a parallelogram, and in this case, it says the doorway shown is part of a building in England. Over time, the building has leaned sideways. We want to explain how we know that that SV is parallel to TU. Well, in this problem, we know that one set of sides is parallel and they're also congruent. We do have a property that says if we have one set of sides that is parallel and congruent, then the figure is going to be a parallelogram. So in this case, we know that SV and TU are going to be congruent. First of all, we prove that it's a parallelogram. If it's a parallelogram, then we know opposite sides are congruent. So again, what we do is we see that ST is parallel to UV and ST is congruent to UV. So there was a theorem that said if we have one set of sides parallel and congruent, then it's a parallelogram. Since it's a parallelogram, then we can state that opposite sides are congruent, so SV and TU are congruent. Okay? And here's another one. It says, for what value of x is the figure a parallelogram? Well, if this is a parallelogram, then not only is CN congruent to NE, but FN is congruent to ND because the diagonals bisect each other. So at that point, we can say 5x minus 8 equals 3x. I'm going to subtract 5x from both sides. And if I do that, I get a negative 8 here because those cancel. And over here we get a negative 2x. Dividing both sides by a negative 2. Those cancel and we get x is equal to 4. So that's the value of x that makes it a parallelogram. And again, we know that CN and EN are congruent, so we want to find it so that FN and DN are congruent. So we do that, we set them equal, we plug in our values, we solve for x. They did it slightly different, but that's okay. Okay, we get x equals 4. And at that point, if we plug 4 into here, we get 20 minus 8, which is 12. And if I plug 4 into here, I get 3 times 4, which is also 12. Okay. What theorem can we use to show that the figure is a parallelogram? Again, we have one set of sides that are parallel and congruent, therefore it's a parallelogram. And don't use the numbers, use the ideas. Here we know opposite sides are congruent, therefore it's a parallelogram. Don't use the numbers, use the idea. And here we have opposite angles are congruent, therefore it's a parallelogram. Again, don't use the numbers, use the idea. And for here, it says for what value of x is it a parallelogram? Well, we know the diagonals bisect each other here, so therefore we know these two lengths are equal. We also know that those two lengths are equal. Therefore, 2x is equal to 10 minus 3x, and if we add 3x to both sides, we get 5x is equal to 10. Dividing both sides by 5, we get x is equal to 2. So therefore, since the diagonals bisect each other, this would be our explanation. We know that 2x has to be equal to 10 minus 3x, and if I plug a 2 in here, I get 4. If I plug a 2 in here, I get 10 minus 6, which is also 4. So again, the number would be 2. The diagonals bisect each other, so solve that. And we're done. Thanks.